Hello again. This is the second video to go along with 3.1a on some application basics. And in the interest of time, I started out writing the first problem. It says the function h of t equals negative 16t squared plus 144t plus 576 gives the height, h in feet, of an object t seconds after being launched in the air. Okay? Before you do anything else, you should be listing what the input is and what the output is. And remember, you've got two clues about that. You can look within the function, t is being plugged in, h is what you're getting out or what you're solving for. Or you can just think about this situation. Time is going to go by, and then I can calculate or see how high the object is in the air. So input is going to be t, which is seconds, and output is going to be h, which is height in feet. Okay, very important to acknowledge, so when you do write your sentences, okay, you're using the correct units. So we know what our input and output are. The next thing I want you to think about is what kind of function is this? And does it make sense in the scenario that they're describing? When you throw something up in the air, okay, and by the way, this is a classic quadratic problem, okay, a classic parabola problem. When you throw something up in the air, you're going to toss it up, it's going to reach a peak, and then gravity is going to pull it down. So it will naturally make the arc, okay? So it'll naturally be modeled with a parabola. So it makes sense that this is a quadratic equation, high power of 2, all right? The next thing to think about is, what do you expect the graph to look like, okay? I'm expecting the ball to be launched in the air from a certain height, okay? Might be 0, might be higher, all right? And we can decide that actually from the formula by knowing the y-intercept. What's the y-intercept of this situation, of this formula? The constant term, the c value, is 576. So the y-intercept is 576 on the y-axis, or 0, 576. So I'm not going to do everything to scale, all right? I just know that this is going to be 576. It's going to get tossed up. It's going to come down, okay? The reason why this picture is so important is because, do I care what happened before I launched the object? Not at all, okay? But keep in mind, this function, when you graph it in your calculator or on Desmos, will show a complete parabola. This is about knowing your domain and your range, okay? Negative t values, negative time, is not going to make sense, okay? So we're not going to have any graph back here. Also, it's always going to get thrown up and come down, but it's not going to go underground. Once it hits the ground, that's it. So there is going to be a stopping value, okay, a low y value. And there's going to be a high y value because it's only go up to a certain height, and that's it, okay? So understand what picture you should be focusing in on. This is the picture in real life that you should care about. So what do you think are some questions that an application like this could ask? It could ask, what is the y-intercept, and interpret, okay? And since we already found that, we can do the interpretation. So we'll do that one first. But what else could it ask? It could ask, how high did the object go? And how long did it take to get there? That's asking about the vertex, okay? And it could ask, when does the object hit the ground? Okay, after how long does the object hit the ground? And then it would be asking for this x-intercept. So those are the questions that we're going to go through here, okay? So first things first, find the y-intercept and interpret. The finding is the more straightforward part, 0, 576. But again, it's 0 what and 576 what. That's why we list it here, makes it easier. At 0 seconds, the object starts at 576 feet. So maybe it's already in a tall building, okay? Makes sense, because you're just talking about how high off the ground it is. Next question could be, when does the object reach a maximum height? Well, right away, the word maximum triggers something, okay, or it should trigger something. I'm talking about the vertex, okay? But it's a when question. So it's not just asking for the whole vertex, it's asking for just part of the vertex, the time part of the vertex. So I can do one of two things here. I can do this strictly on my graphing calculator, okay? Or I could use the axis of symmetry formula, because they're asking me for that particular input to where that occurs. So this is going to be negative 144. I take the b from the formula, divided by 2 times negative 16. Okay? When I work this out, I'm going to get 4.5. Don't stop here, though. Remember, words answer words. So you are not done in a word problem until you got some sort of words with your answer. So this is 4.5 what? 4.5 seconds. Okay? Then the follow-up question to that should be, what is the maximum height? Well, again, you have one of two ways to go with this. You can either get it out of the calculator, okay, find the vertex, you kill both of these answers with one shot, or you do the second part of calculating the vertex and you plug this back into the function. So I want to find what h of 4.5 is. So everywhere I see t, okay, again, the original function is up here. Everywhere I see t, I'm going to plug in 4.5. And again, you could skip all this and just do it in your calculator if it doesn't specify. If you do that, you should wind up with 900. But remember, it's not 900, okay? Units are needed here. Words answer words. So this is 900 feet, okay? So the maximum height is 900 feet if you want to write a complete sentence. The very minimum, though, is units, okay? Last but not least, we want to find when the object hits the ground. What does hitting the ground mean? Hitting the ground mean height is 0, right? No, you're not off the ground. Your height is 0 feet. So I want to know when 0 equals negative 16t squared plus 144t plus 576. Again, I have two options here. I could either use the quadratic formula, which you saw in the previous videos, or I can use technology to find that, okay? In the interest of time, okay, calculator will be quicker. And not only that, it'll help us check our previous answers as well. So we're going to turn to the calculator, okay? I'm going to type in the function, negative 16x squared plus 144x plus 576. What do I have to know about this function? I have to have some idea of a window, but good thing we used our brain first, okay? And that we did the work first, because I know what the maximum height should come out to be. So I'm going to go to my window, and I know no negative inputs matter here, okay? And I want to know when it'll hit the ground. That's what I'm trying to answer here. But now use some common sense. How long do you think something is going to take to get launched into the air and come back down? Okay, it's not going to take very long, maybe 15 seconds. We can count by ones. All right, for our Y's, we're not going to go underground, okay? However, if you want to make this slightly negative, tiny little bit negative, just so you can see where it hits the input axis, you could, okay? But the actual domain and range, this is not going to be negative. And the max, okay, I already figured out a max, should be 900, so maybe I'll go a little higher than that. Maybe I'll go to 920, and I'll count by 20s. Remember that this is really up to you. There's always some leeway here, as long as you're seeing the right features, okay? Let's hit graph. There I see the object going up, makes a nice turn, and it comes back down. This actually turned out to be a beautiful window, okay? I see where I launched it, I see the peak, and I see where it hit the ground, okay? So now I want to figure out what that value is. How long did it take for me to hit the ground? Because remember, this is time, this is seconds, and this is your height, okay? So only this is measuring height. This is measuring how long it took. How long did it take? I want that value. I'm going to go back into y equals, and I'm going to set my y2 equal to 0, because I want to know when is the output 0. Again, look at what we set up here. We're setting this in y1, this in y2, just like we did for the other problems. And I'm going to go back to graph. Okay, it is drawing in a line here. You might not be able to see it, but it is drawing it in. I want to know where they intersect right there. So I'm going to go to second trace. I'm going to choose number 5. Follow the prompts. Hit enter 3 times. And I wind up with a nice number, actually, for this problem. I wind up with a nice 12. So this actually will hit the ground after 12 seconds, okay? So I wind up with t equals 12, okay? So what does that mean? Again, complete sentences here. After 12 seconds, the object hits the ground. The reason that I'm choosing to write it this way and not saying the object hits the ground after is because input, output, okay? Seconds, height, all right? It doesn't really matter as long as you know the interpretation, okay? But I like maintaining that order because it keeps everything straight, okay? Last but not least, if you're asked about the practical domain and range, okay, that's what we set up here before, except now we can actually fill in some values. This height is 900, we found based on our calculations, and this wound up being 12 seconds. Now I know, okay, that my domain, I'll write it over here. Now I know that my domain is from 0 to 12 seconds. That's where I care about. That's where this graph is going to be. And I know that my range is from 0 to 900 feet, because that's going to be where I exit the graph, my maximum height. So Going back to domain and range, this is what we're talking about when it's a practical domain and range. Okay, where does this graph make sense? What values do I need to exclude? Okay, where am I going to have input and output? Okay, that makes sense. Okay, I want to do, so this is a classic quadratic. I wanted to give you an example of another quadratic because you get tired of the distance throwing something in the air, okay? That's the most common type of quadratic problem. So I'm going to give you a different one. Premise won't change though, okay? You just have to know input and output. So the function p of x equals negative 1,000 x squared plus 12,700 x minus 12,200, okay, gives the profit a company earns P in dollars by selling an item for X dollars. Okay, so this might be a little bit tricky to think about, but they're changing the price of their item. Okay, if they sell their item for a cheaper amount, okay, what happens? If they sell their item for a more expensive price, what happens? And this is the profit that they earn depending on the selling price that they decide, okay? So always talk about input and output first. What does this company model depend on? It depends on their selling price. So the input is X, which is their selling price of the item. How much are they going to sell it for? And then that's going to determine P, which is their profit in dollars. And both of these units are dollars. Okay? So again, keep this in mind because that's what's going to drive the rest of the questions. Find the x-intercept or find the y-intercepts and interpret. Finding it shouldn't be an issue, okay? I know that the c value is the y value of the y-intercept. So this is 0, negative 12,200. Interpret. This is why I recommend this. If they sell, quote unquote, sell the item for $0, which means it's free, they give it away, okay, for free, they lose $12,200. Okay, they're in the hole. $12,200. Okay. At what price should they sell the item to maximize their profit? Well, again, I got a clue here. Maximize their profit. Okay, that tells me I should be finding a vertex. Well, instead of doing all of the work with the axis of symmetry and doing it algebraically, let's just do this one in our calculator, especially because the numbers are so big, okay? So we're going to type in negative 1,000 x squared. Oops, I did that backwards. Negative 1,000 x squared plus 12,700 x minus 12,200. All right. Think about what you know about it, okay? Y-intercept, negative. So I have to make sure I adjust my window accordingly, okay? So let's think about what a good window could be, all right? Am I gonna ever sell my product for less than free, okay? No, that doesn't make any sense. They're not gonna, we're not gonna pay them to use our product, okay? So that doesn't make sense. So we're gonna keep that at 0, okay? How much do you think our item could cost, okay? I don't really know too much about this item yet. So maybe I'll go out to $100 and see what that does, okay? Maybe count by tens. We can have negative profit as shown here. So maybe I want to go from negative 12,500, a little bit lower. And I don't know, if I can lose that much, hopefully I'm gaining significantly more than that. So maybe I want to go out to, I don't know, $25,000, and I'll count by thousands. Again, I'm estimating here, I'm guessing here, and then we can make any tweaks later on, but I'm doing educated guesses. Now let's look at the graph, see if we're close. Okay, we went a little too far out with the price of our product. Okay, they're not going to sell it for $100, so we can bring that back in. And we don't quite see the peak, which means we can raise the Y max. So let's go back in and do that. Okay, so I don't need to go all the way out to 100, as we saw, lots of empty space there. So maybe I can go out to $30. Okay, change it by fives. And I have to go a little higher. I'm making more than 25,000, okay, apparently. So maybe I'll go out to 40,000. And now let's go back and look at my graph. All right, much better. I can even narrow it in more, but this is much better because I'm seeing what I need to see. X-intercept, there's 2 of them, Y-intercept, and the vertex. Okay, in this particular question, I'm interested in that vertex. How do I do that? Second trace, it's a maximum, so number 4, follow the prompts. Left side, right side, make a guess. Okay, and I wind up with a maximum of 6.35 approximately, comma 28,122.5. Okay, I'm going to add a 0 here, and I'll talk about why in a second. Okay, why did I choose to round these to 2 decimal places? Because they're both talking about money, okay, dollars. So we in America do cents, okay, 2 decimal places. So that's why I'm rounding these to 2 decimal places, okay? This is only asking at what price should they sell the item. I don't care about this right now. I care about this, okay? They should sell the item at $6.35 to maximize profit. Can you guess what the follow-up question to that would be? The follow-up question to that would be, what is the maximum profit they could make? Good news is, we've already kind of answered that by looking for the vertex. The maximum profit is $28,122.50. And the last question would be something like, when or how much do they need to sell the item for to break even? Okay, breaking even is a business term. That means you haven't made a profit. Okay, so we're talking about a 0 profit. That means I want to solve 0 equals the negative 1,000x squared plus 12,700x minus 12,200. okay? I am not going to try to solve this by hand, okay, using the quadratic formula. I could, okay, and you should be able to, if you want to check your work, obviously do both, okay? Do the algebra with the quadratic formula and use your calculator. So we have it already in here, okay? I want to know when they break even. There's two places where they break even, okay? So I need to find both of them, okay? Before I do that, I'm going to go into Y2 and I'm going to set Y2 equal to 0 because I want to know when is their profit 0. That's an output. Go back to the graph. You might not see a line, but they're drawing a line right on the input axis. I'm looking for those 2 points of intersection. Second trace, number 5. We have to follow it twice, remember? So I have to go to the first point of intersection, hit enter 3 times. They could sell it for $1.05. So X could be approximately 105. And do it again. Bring it over to the other side. Enter 3 times. Or X could be approximately $11.65. Okay, and again, write those in complete sentences. I won't do that just for the sake of time for this video. So I think I'm actually going to break this up into 3 videos. Okay, I'm going to do one more for linears. And then, so I will see you in the next video. Please be doing your practice here because every word problem is different. Okay, see you in the next video.